Last time we were doing second order differential equations type 2. We did some differential equations which involve polynomials. Now we are going to some examples involving exponential functions. So we are now moving to example 3. Example 3. So solve the d squared y, dx squared minus 6 dy dx plus 5y is equal to 7 exponential 2x. Given that when x is equal to 0, y is equal to 1, and dy dx is equal to 3. So solution to this, our y will be equal to yc plus yp. yc plus yp. This implies what? D squared minus 6d plus 5 into yc should only give us 0. From here we generate the auxiliary quadratic equation, which will be equal to m squared minus 6m plus 5 is equals to 0. This is m minus 5 into m minus 1 is equals to 0. So m is equals to 5 or 1. Therefore, our yc will be equal to ae power 5x plus be power x plus be power x, where a and b are arbitrary constants. So we are in the process of now determining the particular integral. So we let our yp be equal to, since we have an exponential function on the right hand side of this differential equation, we are going to let our yp to be equal to arbitrary constant k multiplying the exponential 2x. The exponential, we maintain it, but the arbitrary constant is not known until we determine it. Remember, we are using method of undetermined coefficients. So yp prime, the first derivative will be 2k exponential 2x. Second derivative will be equal to 4k exponential 2x. But we know something, d squared minus 6d plus 5 into yp. This is the only one which will generate 7 exponential 2x. So d squared multiplying yp, the second derivative of yp, which is 4k exponential 2x. D times yp first derivative. First derivative times minus 6. We get minus 12k exponential 2x. Plus 5 multiplying yp. We have 5k exponential 2x. And this is what we equate to 7 exponential 2x. This implies what? We add all this because they are the same, so we add their coefficients, 4k minus 12k plus 5k. We get minus 3k exponential 2x. This one is equal to 7 exponential 2x. Minus 3. This implies what? Our k now is equal to negative 7 all over 3. Our k is equal to negative 7 all over 10. Therefore, our yp will be equal to minus 7 all over 3 exponential minus 7 all over 3 exponential 2x. The general solution, y will be equal to yc plus yp, which will be equal to ae power 5x plus be power x minus 7 all over 3 exponential 2x. Since we were to determine the particular solution, because some conditions were given, we can go for particular solution. And before we go for particular solution, we need to determine dy dx. So dy dx will be given by, if y is equals to this, dy dx will be 5a exponential 5x plus be exponential x minus 14 all over 3 exponential 2x. So picking on the conditions, we have when x is equals to 0, y is equals to 1. When x is equal to 0, y is equals to 1. This implies what? Now our y is 1, x is 0. So we'll be having a plus b minus 7 all over 3. This implies what? A plus b will be equal to 1 plus 7 all over 3, which gives us 10 all over 3. It gives us 10 all over 3. So a plus b is equal to 10 all over 3. We'll call this one equation 1. We go for another condition. When x is equal to 0, dy dx is equals to, when x is equal to 0, dy dx is equal to 3. So we say 3 is equals to, we go to this expression, we get 5a plus b minus 14 all over 3. That is when x is equal to 0. Now we can see here 5a plus b will be equal to 3 plus 14 all over 3. 3 plus 14 all over 3. 3 plus 14 all over 3 gives us now 23 all over 3. 23 all over 3. 23 all over 3. Yeah, we call this one equation 2. Call that one equation 2. Now, we are going to solve equation 1 and equation 2 simultaneously. And we can use any method that we know for solving simultaneous equations. Now here we can use elimination, we can use substitution. Let's use elimination, so we can say subtract, subtract 1 from 2. 1 from 2. We are subtracting 1 from 2. 5a plus b is equal to 23 all over 3. And a plus b is equals to 10 all over 3. So when we subtract, we get 4a. 4a is equal to 13 all over 3. 13 all over 3. So our a is equal to 13 over 12. Our a is equal to 13 all over 12. Now from equation 1, we can now get the value of b. From equation 1, we can get the value of b. So from equation 1, b is equal to 10 all over 3 minus a, which is equal to 10 all over 3 minus 13 all over 12. Minus 13 all over 12, which gives us 27 all over 12, which is basically equal to 9 all over 4. Which is 9 all over 4. That's the value of b. Therefore, our particular solution, y will now be equal to a, 13 over 12, exponential 5x, b, 9 all over 4, 9 all over 4, a power x, then minus 7 all over 3 exponential 2x. And that is the particular solution to that differential equation. Now we move to example 4. Move to example 4. So solve the d squared x dt squared minus 4dx dt plus 4x is equal to 5 exponential 2t. So here x is a function of t. So in our solution, we say we are solving for x, which will be equal to xe plus xp. This implies what? D squared minus 4d plus 4 into x c should be equal to 0. From here we get the auxiliary quadratic equation, or the characteristic equation, which is m squared minus 4m plus 4 is equals to 0. This is m minus 2 into m minus 2, which is equals to 0. So m is equals to 2, which is appearing twice. M is equal to 2 times, that is twice. Therefore, our xc will be equal to a power 2t into at plus b into at plus b. From there, we start now the process of determining the particular integral. So we let xp to be equal to a constant multiplying e power 2t. Here there is a constant multiplying e power 2t, so we put this one as a arbitrary constant multiplying e power 2t. But before we proceed, we check our complementary function. If we have something like that already contained in our complementary function, from here exponential 2t times b give us b exponential 2t, which will resemble that. So we don't want a duplication. So we deviate from whatever is already contained in this. So we deviate by multiplying by t. Again we check if now we are safe. When we check here, exponential 2t multiplying at. This will be a multiplying t multiplying exponential 2t. It resembles that because that is k t exponential 2t, which is the same as, which is similar to at exponential 2t. So it is already contained here. So we deviate further from whatever is contained in our complementary function. So we multiply this by another t, which will take it to t squared. So kt squared exponential 2t. When you now check this complementary function, we don't have such a term here. That term is standalone, and it is not in this particular complementary function. Therefore, that would be the correct letting for xp for the particular integral of this differential equation. Now, after knowing it is the correct letting, we can operate on it and get the first and second derivative. Let's get the first derivative. This is a product of two functions. We are going to keep this one constant, differentiate this. So we'll get 2k t squared exponential 2t plus, now we keep exponential 2t constant, differentiate t squared, we'll get 2k, then t e power 2t, e power 2t. We go for second derivative. Second derivative, we are here now. Differentiate this, 2 will come forward, so it will be 4k t squared e power 2t plus, we now differentiate t squared, 2 comes forward, it will be 4k t e power 2t. We come to this, we differentiate exponential 2t, we keep t constant, so it will be plus 4k t e power 2t plus now we keep exponential 2t constant, differentiate t, we get 1, we get 2k exponential 2t, which simplifies to what? 4k t squared e power 2t plus 8k t e power 2t plus 2k e power 2t. But we know something. D squared minus now 4d plus 4 into xp. It is the one to generate 5 exponential 2t. It is the one to generate what we had on our right hand side of the differential equation. From this now, d squared times xp. D squared times xp, it is the second derivative, which is this, we write it down, 4k t squared exponential 2t plus 8k t exponential 2t plus 2k exponential 2t is equal to not is equal to, we have not subtracted those other ones. So minus 4 times the first derivative of xp. So 4 times this. So we say minus 8k t squared exponential 2t minus 8k, this multiplied by negative 4, 8kt e power 2t. Now plus 4 times the value of xp. So 4 times this, 4k t squared exponential 2t, which will be equal to 5 exponential 2t. Now this 4k t squared plus this is 8, 8 minus 8 is 0. 8k t exponential 2t minus this 8 is also 0. So we say this implies what? 2k exponential 2t will be equal to 5 exponential 2t. This implies what? 2k is equals to 5. Therefore, k is equals to 5 all over 2. Therefore, k is equals to 5 all over 2. Therefore, the GS, the general solution, will be equal to XA plus XP, which will be equal to A power 2t and AT plus B plus 5 all over 2, 5 all over 2 t squared E power 2t. Since our XP was kt squared exponential 2t, and our k is 5 all over 2. Now t squared exponential 2t. And this is now our x. And that's the solution, the general solution to that differential equation. That's the general solution to that differential equation. Now we are moving to example 5. Now example 5 is one which involves trigonometric function on the right hand side of the differential equation. So we say solve the dE, d squared y dx squared plus 3 dy dx is equal to 4 cos 2x, given that when x is equal to 0, y is equals to 2, and dy dx is also equal to 0. Dy dx is equal to 0. So in our solution for this, since y is a function of x, we have dy dx, y will be equal to yc plus yp. This implies what? Our d squared plus 3d. This one multiplying yc, we are supposed to get a 0. The auxiliary quadratic equation will be what? M squared plus 3m is equals to 0. So m into m plus 3 is equal to 0. So m is equal to 0 or m is equals to negative 3. Therefore, our yc will be equal to a plus b e power minus 3x. Power minus 3x. Now, after getting the complementary function, we proceed now to establish the expression for our particular integral. And we're using method of undetermined coefficient. And since this is a trigonometric term, we said if it is a trigonometric term, then we are going to let our yp to be equal to k1 sine, the value that is here, sine 2x, plus k2 cos 2x, plus k2 cos 2x. Now we check our complementary function. Our complementary function does not have a constant multiplying sine 2x or a constant multiplying cos 2x. So whatever we have there is quite different from what we have here. So that would be the valid rating for our particular integral. Therefore, we can operate on it, get the first derivative. The first derivative will now be 2k1 cos 2x minus 2k2 sine 2x. Second derivative will now be minus 4k1 sine 2x minus 4k2 cos 2x. But we know something, but d squared minus d squared plus 3d into plus 3d into our yp. It is the one to generate 4 cos 2x. 4 cos 2x. This implies what? We take the second derivative, we write minus 4k1 sine 2x minus 4k2 cos 2x minus 4k2 cos 2x, then plus 3 times the value of the first derivative. So plus 6k1 cos 2x minus 6k2 sine 2x. So this is what should be equated to 4 cos 2x. So this implies what? Let's collect terms that multiply sine 2x. We can see minus 4k1 is multiplying sine 2x. We have minus 6k2 is also multiplying sine 2x. Plus those terms that are multiplying cos 2x. The coefficients of those cos 2x are minus 4k2 and plus 6k1. This one goes with cos 2x. And this one is equals to 4 cos 2x. Comparing coefficients. Comparing coefficients. Comparing coefficients. Comparing coefficients, what do we have? Coefficients of sine 2x. We are getting minus 4k1 minus 6k2 is equals to 0. There is no sine 2x on the right hand side. For cos 2x, comparing coefficient. Coefficient on the left hand side we have minus 4k2 plus 6k1 plus 6k1 plus 6k1 is equals to yeah. This one is equals to 4. That is for cos 2x. So if that is the scenario, we need now to solve these two simultaneous equations. We need to solve those two simultaneous equations. And we're now solving. This one we call it equation 1. This one we call it equation 2. Now from equation 1, we can see clearly minus 4k1 is equals to 6k2. So k1 is equal to minus 3 all over 2 k2 minus 3 all over 2 k2. Substitute for k1 in 2 in equation 2. We're substituting for k1 in equation 2. What do we get? We get minus 4k1 minus 4k2 plus minus 4k2 minus 4k2 plus 6k1. So 6 into minus 3 all over 2 k2. And this is what should be equated to 4. This is minus 4k2 minus 9k2 is equals to 4. So our k2 will be equal to minus 4 all over 13. Minus 4 all over 13. Therefore, our k1 will be equal to minus 3 all over 2 into minus 4 all over 13, which gives us minus just 6 all over 13. So, times 3, 6, yeah. 6 all over 13. Therefore, our YP will be equal to what? K1, 6 all over 13 sine 2x plus, not plus because our K2 is a negative, minus 4 over 13. 4 over 13 cos 2x. Minus 4 over 13 cos 2x. That is our YP. Therefore, the general solution, y will be equal to yc plus yp, which will be equal to what? We had a plus b e power minus 3x. Now plus 6 all over 13 sine 2x plus, no, not plus, minus 4 all over 13 cos 2x. Cos 2x. That is the general solution. And since we are given some conditions, we can go up to particular solution. So We are given, we need a dy dx before we put in our conditions. So dy dx will be equal to, when we differentiate this y, we get minus 3b exponential negative 3x. When we differentiate 6 all over 13 sine 2x, we get plus 12 over 13 cos 2x. When we differentiate 4 over 13 cos 2x, we have a minus, minus and a minus will be plus, plus 8 all over 13 sine 2x. So we say when x is equal to 0, y is equals to 2. When x is equal to 0, y is equal to 2. So this implies 2 is equals to a, when x is 0, a plus b minus 4 over 13. This implies what? A plus b will be equal to 30 all over 13. A plus b is equal to 30 all over 13. So this one we call it equation 1. So we say when x is equals to 0, dy dx was also equal to 0. So from here we see in the expression of dy dx, where there is a dy dx, we insert a 0. Now where there is in also x, we also insert a 0. So this one will give us minus 3b, since exponential 0 is 1, plus 12 all over 13. And this one will go to 0. So from here we can see clearly 3b then is equal to 12 over 13. Therefore b is equal to 12 all over 39. B is equal to 12 all over 39. So b is equal to 12 over 39. So from expression 1, we can say from equation 1, our a then will be equal to 30 all over 13 minus a, minus b. So 30 all over 13 minus 12 over 39, which gives us 78 all over 39. 78 all over 39, which you can simplify further. 78 all over 39, which we can simplify further. 26 all over 13. That is 26 all over 13. Yeah. Therefore, the particular solution y will be equal to a, 26 all over 13, plus b, 12 over 39, exponential negative 3x, plus, we have plus 6 all over 13 sine 2x, minus 4 all over 13 cos 2x. And that is the solution to that differential equation. That is the solution to that differential equation.